All right, so we're going to be working on 1.7 day 3 today. We're going to continue modeling with functions. Okay, my pen. So a little review of our 12 basic functions. Your linear function is, we're going to be doing scatter plots today. So if you plotted a bunch, if you plotted a bunch of points, get it together here. If you plotted a bunch of points and you thought maybe, you could best go through them with a line, then when you do regression, you're going to pick a linear regression. If you end up with dots that kind of make a parabola shape, if you connected them or tried to connect them, then you would pick quadratic. If you got an S-looking thing, okay, that would be cubic. Quartic would look something like this. Natural logarithm has that kind of a curve to it. Exponential, that's when it starts off low and gets big really fast. Exponential, when b is less than 1, would be coming down really fast. A power function, okay, kind of looks like half a square root function. Logistic, you won't have those. Sinusoidal, okay. So part of your homework is just going to say, tell which of the following types of regression is likely to give the most accurate model for the scatter plot shown: linear, quadratic, cubic, exponential, or sinusoidal. Well, if I were to try and connect these dots, the closest shape to any of the 12 I could make would probably be a line. So I would say it's a linear regression. And I would say that this has a strong positive correlation because I'm heading up and I can hit most of my dots. Okay? Here, if I tried to connect the dots, I get a U shape. That would be a quadratic regression. Okay, and I would say it's pretty strong because I can hit most of those dots. So I'd say there's a strong correlation there. Okay, so hit pause, and we're back, and it looks like an S shape, which would indicate cubic. If I try to connect those, I get that S shape, which would indicate a cubic regression. Okay, this one, it's starting low and it's getting big real fast. Some people might think, well, if you kept going, it would make a parabola. Yeah, but my data's not over there. So I would go with exponential because it's starting small and it's getting big really fast. Okay, on this one, hit pause. And we're back. If I try to connect these, I make a parabolic shape, so I'm going to go with quadratic, and I'm right. So how can you identify which of the 12 basic functions most appropriate models real world? Well, mostly by its shape. And how do you determine how well your regression equation models the data? Well, how many dots it hits. If it hits a lot of the dots, then it's strong. How many dots it hits? And that will tell you if it hits a lot, then it's strong. Okay? All right, manufacturing. When you manufacture stuff, it's going to cost you money to make what you're selling, and then you're going to make money based on what you're selling. So you're going to have two equations. It says the boogie board company determines that the annual cost C of making X amount of boogie boards is $50 per board, plus $95,000 in fixed overhead costs. Each boogie board that is manufactured is sold wholesale for $75. So it says find an equation that models the cost. Well, my cost equation is going to be, it's $95,000 up front. It's going to take me that much to get overhead. Plus, it's going to cost me $50 per board. Touching, per. Okay? Find an equation that models the revenue. Revenue is what you make. And you're going to make $75 for every board you sell. So C says, find how many pairs of boogie boards must be made and sold in order to break even. You can use systems of equations. We're going to use the graphing calculator. So if I go to Y1 and type in my first equation, go to Y2 and type in my revenue equation, all right, adjust my window. This first one, my cost function goes all the way up to 95,000. So I have no idea how far out I'm going to have to go, but I went from 0 to 5,000, counted by hundreds, and 0 to 400,000, and I counted by 10,000s. And if I hit my graph, you can see the intersection. Now, mine is color, which makes it nice, because you can see the blue line. The blue line is actually my cost function, and the red line is actually my revenue function. And right here at their intersection point is where it's broken even. So when x equals 3,800, y equals 285,000. Now what that means is, if I make 3,800 boards, it's going to cost me $285,000. It also means if I sell 3,800 boogie boards, I will make $285,000. So I've broken even. At this point, I'm exactly even. I haven't made more money or lost more money. I'm exactly dead even. Okay? So it says graph the equations in A and B, and what is the graphical interpretation of the answer in C? Well, what I would say is, if you are going to make anything less than 3,800 boogie boards, it's going to cost you more than you make. If you make more than 3,800 boogie boards, then you're going to make more than it costs. So I suggest you make more than 3,800 boogie boards. Okay? Alright, next, it's the same problem, they just changed the numbers. This is actually your homework problem 49, or like it. Okay, so it says the boogie board company determines that the annual cost C of making X amount of boogie boards is $45 per board, plus $100,000 in fixed overhead costs. It costs the company $9 to wax the board. The company sells the unwaxed boards for $80 and waxed boards for $90. So for A, it says find a function y sub 1 such that models the cost of producing X unwaxed boards. Okay, so if we're doing cost, my cost function for unwaxed, I'll put UW, is going to be the 100,000 plus to make a, what are we doing, unwaxed board? It costs $45 per board. That's without waxing it, so that would be $45 per X. But if I want to figure out how many waxed, or the cost of making waxed boards, okay, that would be, my cost would be the 100,000 plus, it's going to cost 45 plus an extra 9 to wax the board. So 45 plus 9 is $54 per board. Okay. For Y3, the revenue from selling X unwaxed boards, well, for getting unwaxed boards, we sell them for $80. So that revenue would be $80 per board. For waxed boards, I get $90. So my revenue for waxed boards would be $90 per board. Okay. Now it says graph all four simultaneously in a window where you can see all intersection points. So I typed the first, second, third, and fourth equation in, and I did my window as such, and I graphed. Okay. The blue line is your unwaxed boards, unwaxed cost. The orange line is your waxed cost. The black line is your revenue for unwaxed. And the purple is your revenue for waxed. Okay? So F says, write a report to the company recommending how they should manufacture their boards, waxed or unwaxed. I don't know what the rest of that said. If you were to write a report, if you look at these intersection points, I'm not going to do it all for you. You guys need to analyze this, because you can come up with lots of reports based on how you analyze your data. And that's what mathematicians do. You could look at where unwaxed intersects waxed. You could look at revenue versus revenue. You could make all kinds of decisions. You have these four intersection points here that you could talk about. Okay, So your report would be interesting to me based on this data, but everybody would probably have a different report. Okay? All right, benefits. Define your original salary. Add your increase to your original salary for each benefit that the company contributes. Set it equal to the total worth and solve for X. So it says Valerie's company issues employees a contract that identifies salary and the company's contributions to pension, health insurance premiums, and disability insurance. The company uses the following formulas to calculate these values. Your salary is X dollars. Your pension is 14% of your salary. Your health insurance is 3.5% of your salary. Your disability insurance is 4% of your salary. If Valerie's total contract with benefits is worth $55,950.38, what is her salary? Well, wouldn't we take her salary plus her the pension, right? That's 14% of the salary, plus her health insurance, that would be 0.035 of the salary, plus her disability insurance would be 0.004, right, of her salary. And altogether, that's worth $55,950.38. All of that adds up. So if I just want to figure out what her salary was to begin with, I need to solve this. So if I add all of those up, and I don't have my calculator, oops, sorry. If I add all of those up, I get 1 plus 0.14, sorry, 1 plus 0.14 plus 0.035 plus 0.004, that's going to be 971, 1.179, yes? So I have 1.179x equals 55950.38. To get x alone, I'm going to divide by 1.179, and I get x equals whatever that comes out to be. Give me just a second. Sorry, I need to get my calculator. So if I type in 55950.38 divided by 1.179, I get x equals $47,455.79. That's her original salary. The reason she gets all this is because of all of the benefits. Okay, but her actual salary is only $47,455.79. All right, constructing a function from a data. You already know how to do this. You're going to make a scatter plot on our calculator. You put your x's in L1, your y's in L2. Determine from the shape what kind of function you think it is, and then pick the correct regression. So on this one, it says it records the low and high daily temperatures observed on 9/9/1999 in 20 major American cities. Find a function that approximates the high temperature as a function of the low temperature. Use this function to predict the high temperature that day for Madison, Wisconsin, given that the low was 46. So we're comparing, it looks like, lows to highs, yes? And they're telling me that the high temperature is my y's and the low temperature is my x's. So we're going to go to our stat and we're going to enter in all of our x's and enter all of our y's. We're going to change our window. Okay, you guys can do this on your own. You're going to change your window and it should plot those points. Well, if you had to decide, I don't really see a curve, I don't see an S. Really, they seem kind of like they're following a linear kind of path going up. Okay, so I'm going to choose a linear regression. Okay, there's the window that they used, by the way. And then I would calculate it. Oops, excuse me. I would calculate it. I would calculate that, okay? I didn't type this all in. Give me just a, and I won't have time to type it all in, but you should get a linear, you would predict a linear regression, okay? Hold on just a second. And we're back. I apologize. I don't have time to type all this in for you. So I went and looked it up in the book, and you type it in and see if you get something close to 0.97x plus 23. Okay, the second part says use this information or this function to predict the high temperature that day for Madison, Wisconsin, given that the low was 46. Lows are x's, so they're telling me to replace x with 46. And if I type that in, I get 67.62. So I'm going to say that the high for that day was approximately 68 degrees. And if we look for Madison, Wisconsin, is it on there? No, but that's what it would be, I guess. Okay? All right, so next, they're just asking you some in general questions. It says, true or false, the function y equal x squared minus 1 squared over x minus 1 is continuous at x minus 1. If you plug this in, I would have, I don't really care about the top, but on the bottom, I would get what? 0. If you get 0 in the denominator, it's not continuous there. There's going to be a jump. So this one is false. Okay? All right, sketch the graph, and at which of these points is the function decreasing? You can either do it on your calculator, or you could just sketch it. Negative x squared is just going to be the mother function turned upside down. Well, at -4, or you could type it in.
Good morning, everyone. We have a few important announcements before lunch.
Sorry about that. All right. So if we're trying to decide where the function is decreasing at, if I go to -4, down here it'll be on the graph. But if you read the graph left to right, it's increasing, 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 increasing to 0, right? So -4 is increasing, -2 is increasing, 0 isn't either. It's like the vertex. And then so at 2, is it starting to decrease? Yes, so the only one it's decreasing at is 2. Okay? Next, it says, what symmetry does the graph exhibit? Well, if you folded it over the x-axis, this thing would look like this. If you folded it over the origin, it would, no, not that, okay, it would flip backwards, which would still look the same, and then flip upside down, which would still look like that. Y-axis is when you flip it over this side looks like this side, and this side looks like this side. If I flipped this over the y-axis, I would get this picture. So it's got y-axis symmetry. Okay? And this one would be origin, because if I reflected this over here and then down, I get the other part of the picture. If you have to reflect part of it twice to get the other half, that's what we call origin symmetry. Okay? All right, and we are done. So have a wonderful day, and I will see you next time.